2.4 Solving systems of equations by graphing. A system of equation is two or more linear equations that have the same variable, x and y. A solution to the system of equation is an ordered pair, which is x comma y. The first thing we're going to do is check whether an ordered pair is a solution to the system of equations. So for number 1, is 2, 5 a solution to this system of equations? We are going to plug in x and y into both of the equations to see if it makes these equations true. And if it does not work for one equation, then it does not work. It is not a solution. It has to work for both. So the first equation, x plus y is equal to 7. We're going to plug in 2 for x, 5 for y, and that should equal 7, and it does. So this is true. Now let's check equation 2. So we're going to plug in 2 for x and 3 for y, or 5 for y. 4 minus 15 equals 7. That is not true. 11 does not equal 7. So therefore, this is not a solution. That order pair is not a solution to the system. For number 2, we are going to check if negative 2, 0 is a solution to this system of equations. So we're going to plug in negative 2 for x, 0 for y. So for the first equation, 0 equals negative 2 times negative 2 minus 4. So 0 is equal to 4 minus 4. So 0 is equal to 0. That is true. For the second equation, 0 is equal to negative 2 plus 4. 0 is equal to 2. Not true. So therefore, that order pair is not a solution to that system. So at the bottom, for number 1, we are going to see if 3, 1 is a solution to this system. So we're going to plug in 3 for x, 1 for y. So 3 plus 1 equals 4. 4 equals 4. Yep, that works. And then we're going to plug in 2 times 1 minus 2 times 3 minus 1. Does that equal 3? So 6 minus 1 equals 3. It does not. So 5 equals 3, not a solution. So this will be no. So for number 2, x is 1, y is 3. So we're going to plug this in. We have 1 minus 3 equals negative 2. Negative 2 equals negative 2. That is true. Now let's check the other equation. We have 2 times 1 plus 3 equals 5. And that's 5 equals 5. So yes, this is a solution. And for number 3, we have x is 2, y is 0. So 0 equals 2 minus 2. 0 equals 0. That is true. And 0 is equal to negative 3 times 2 plus 6. So 0 equals 0. Yes, that's true. So yes, that ordered pair is a solution to the system. All right, let's do some graphing. So solving a system of linear equations by graphing. So you graph each equation, and the point where those two lines intersect is the solution to the system of equation. So let's look at number 10. We're going to graph x plus 3. So our slope is negative 1. I'm going to write it as a fraction. And then our y-intercept is 0, 3. So let's graph our y-intercept first, 0, 3. And then our slope, we're going to go down 1 to the right 1, down 1 to the right 1. And then we have our line. Now let's graph the other equation. So our slope for this one is 1. So I'm going to write that as a fraction. And our y-intercept is 0, 5. So at 5, I'm going to put my first point, and then we're going to go up 1 to the right 1. Now you also can go down 1 and to the left 1. Remember, 2 negative directions or 2 positive directions for a positive sloping line. So the point of intersection is at -1, 4. So therefore, that's your solution. So you can check this. So you can plug in -1 for x and 4 for y into both equations to check to make sure you have the right solution. It may be important when you can't tell where the line intersects exactly. So for number 10, we have 4 equals -1 plus 3. So 4 equals 4. That is correct. And I'm going to check my other solution, my other equation to make sure the solution works. 4 equals -1 plus 5. So 4 equals 4. That also works. So yes, this is the solution, definitely. All right, so for number 11, we're going to graph our slope and y-intercept. So our slope for this first equation is 1/2. Our y-intercept is 0, 2. So 0, 2 is our first point. Rise 1, run 2. Rise 1, 1, run 2. All right, this is our first line. And then our second line, our slope is 1/2. Our y-intercept is 4. So 4, 0, or 0, 4. And then we're going to go, because that's negative, down 1 and to the right 2. Down 1 to the right 2. So our point of intersection is our solution, which is at 2, 3. And that's our solution. And you can also check that to make sure it's right. All right, so for number 12, we have 2 lines. Y equals -3 is actually a horizontal line, if you remember from last lesson. And then we have to find the slope and y-intercept for 3x minus 2y is equal to 6. I'm going to use the formula that I gave you if you find your a, b, and c. So your slope is -a over b. So our slope is -3 over -2, which is 3 over 2. And then our y-intercept equals c over b, which is 6 over -2. So our y-intercept is going to be 0, -3. So let's graph that. 0, -3 is your first point, and you're going to rise 3 and run 2. So I really only need 2 points because I see that one of the points is shared with my line y equals -3. So this right here is my solution, which is 0, -3.